Lizzie, Abe. 80% of Asian people have a variant of gene coding for the enzyme alcohol dehydrogenase called ADH1B, and almost all Chinese people have a variant called ADH1C. The form of alcohol dehydrogenase coded for by these genes converts alcohol to acetaldehyde more efficiently than other gene variants. Another gene variant, the ALDH2 gene, inhibits acetaldehyde dehydrogenase, which is needed to break down acetaldehyde. Therefore, those with the RS671 allele will metabolize alcohol more efficiently and so won't feel the buzz, but will have other nasty side effects. This is known as Asian flush and results in the affected person becoming flushed, having heartburn, migraines and thus feeling ill. The RS671 allele is native to the Han Chinese of central China, where Lizzie's family originates, whilst Abe's ancestors come from Taiwan. Interestingly, it is believed that the allele has been positively selected for in the past, not only due to the spread of rice cultivation, but also as higher levels of acetaldehyde may have provided protection against parasitic infections. Therefore, Abe may feel tipsy first, but Lizzie will feel like she's drunk first. You've got to give an Eastern European country the edge with regards to this question purely for cultural and environmental reasons. Illicit or non-commercial alcohol consumption is so high in Eastern Europe that it renders statistics on official alcohol sales nearly useless. Non-commercial alcohol, traditional beverages produced for home consumption, moonshine, usually with over 40% alcohol, account for nearly half of the total alcohol consumption in Romania. Due to a lack of comprehensive and flexible alcohol policies in Romania, its inhabitants develop an increased tolerance to alcohol compared to most European countries, except Russia and Ukraine. Some believe 10 to 20% of people have a version of the gene that offers some protection against alcoholism. One of the factors that affect a person's likelihood of becoming an alcoholic is their early experiences with alcohol. Those who show a higher tolerance during these first occurrences tend to drink greater amounts in the future. A genetic region at the end of the long arm of chromosome 10 was associated with alcohol tolerance. This region contains the gene that produces the CYP2E1 protein, which is involved in breaking down alcohol as well as other chemicals. Variations in this gene could therefore potentially affect alcohol tolerance. Researchers suggested that none of the regions tested are likely to be the only regions affecting alcohol tolerance. Genetic variations in or near the above-mentioned gene affect the level of response to alcohol, providing a predictor of risk of alcoholism. I will have to say the Finnish male. It was not long ago that a study in Finland showed that men who had been jailed for violent behavior as a result of the overconsumption of alcohol had something similar in common. A strange mystical thing happened. The 14 genes were analyzed at the beginning of the study and a mutation on the HDR2B was found. This mutation leads to the introduction of a stop codon that stops transcription of the serotonin receptors in the frontal lobe, and especially the area that controls impulses. Serotonin can thus not be received. 17 of the 96 inmates carried this mutation and all had committed numerous crimes. Further research on mice that were bred with this mutation showed also higher levels of testosterone, but other factors should be kept in